Hi, it's Jan Peter, and today we are going to take a look at a fully open source new 8-bit computer system, the AGON Lite. So as you can see, it's a small system designed to be both very inexpensive and versatile. And it is actually a true 8-bit system running a true 8-bit EZ80 F92 CPU, which is a modern incarnation of the Z80 or Z80, whatever you want to call it, processor from back in the day. That processor is running at 18.432 megahertz, which makes it equivalent to an old school Z80 running at approximately 55 megahertz. So this is super fast compared to the original 8-bit systems. It has a little Arduino-like chip, an ESP32 Pico, running at 240 megahertz as the video processor. And it has 512 kilobytes of system RAM, which is static RAM used by the CPU. It has 8 megabytes of audio-video RAM used by the little microcontroller VDP chip. It can display 64 simultaneous colors at a maximum screen resolution of 640 by 480 pixels, and it is an instant-on system. In this configuration, it runs BBC Basic right after you turn it on. And here's a banana for scale. So the whole project actually started, So the whole project started with a dream that Bernardo Kastrup, who also designed the Cerberus 2080 computer that I took a look at in a previous video. He had the dream ever since he used his ZX81 back in the day to be able to control devices with programming them in BASIC from his ZX81. So he kind of wanted a microcontroller that was able to control things and to measure things, but he didn't get very far with his pretty limited ZX81. And now he and the AGON Lite team were finally able to fulfill that dream, kind of, with the AGON Lite hardware. So let's take a closer look at this. So apart from this being a fully self-contained 8-bit microcomputer with VGA out, with an audio out, with a little SD card for storage, with an input for a PS2 keyboard or a USB keyboard that is PS2 compatible through one of these adapters. Power comes through this USB plug here. It also comes with a reset switch. Apart from this being a fully self-contained computer, 8-bit machine running BASIC, we also have GPIO pins on here that are programmable via the BBC Basic. So this is a very fast and very inexpensive true 8-bit microcomputer running a real 8-bit microprocessor. No FPGAs or anything like that. The only thing that comes close to that is the microcontroller used for the graphics and the sound. But that is basically used as a separate custom chip in here. And to keep the cost down, the design team decided on using a pre-existing microcontroller, which is independent of the CPU. So it is not used as a CPU, but just as a graphics and sound processor. The processor in here is the Z80, just running at higher clock speeds as the old school Z80s were able to run at. It is very instant on, so you plug the power cable in and you instantly get a basic prompt like back in the day. The GPIO header is addressable through the BASIC, and this is fully customizable. The firmware on here can be customized. There are basically endless possibilities. And on top of that, the whole project is open source. Both hardware and software are open source. This is designed to be about $50 US to manufacture, which makes this kind of a true computer for the masses, not the classes, in the best sense of that statement. I think I have everything I need to actually try this. I'm going to hook it up to my monitor, and I'm going to hook up a simple USB power adapter to the USB input on this, and also a PS2 keyboard that I have lying around. And then we're going to have a look at what this thing can actually do. So I hooked up a PS2 keyboard. VGA is connected to my monitor here. I'm going to plug this into my iPhone charger, which I use as a power source. And we get a basic prompt. And apart from Bernardo Kastrup working on this, it was also Jeroen Venema and Dean Belfield who helped bring this to life. Dean Belfield did the port of BBC Basic, which is still maintained by RT Russell, actually. I'm going to link that in the video description. And he ported it to the AGON Lite. Dean Belfield did that, better known to the community as Break Into Program. Yeah, basically this is BBC Basic. We can program this just as you would program any BBC Basic interpreter. Basically. Just got to keep in mind that BBC Basic is actually case sensitive, so all the commands have to be uppercase. But yeah, and as you can see, it's plenty fast for a basic system. This is just my simple little demonstration program. Yeah, you can use this like an old school basic machine to start with, which is kind of amazing. And BBC Basic is a basic dialect that's pretty cool, pretty sophisticated basic, aimed at learning programming actually. That was the intention of the whole BBC Basic project originally. And it's still one of the most widespread basic dialects actually, I think. So this is a standard programming language still. The first thing I'm going to do is to try and upgrade the firmware on this so we can run the latest example programs. I actually procrastinated making this video for quite a while, and there have been several updates for the firmware in the meantime, so we need to do that. But it's also an opportunity to show you how easy it is to upgrade the firmware on this thing actually. So let's do that. So we are just going to pull the plug, the power plug, to turn this off, and we're going to remove the little SD card or micro SD card from this slot here. We're going to have to copy some stuff on this to be able to upgrade the firmware. And there is a pretty easy to use, allegedly, AGON MOS firmware upgrade utility. MOS is just the name of the firmware, probably a nod to MOS, the chip manufacturer from back in the day, who made the 6502 processor and other things. And yeah, we need the legacy version because the generic version of the upgrade utility needs firmware 1.02. We are on firmware 1.01, so we need to use the legacy version that can upgrade our AGON to the latest version. We just need to copy this into the root directory of our microSD and then run these commands to do the upgrade. And we're going to copy those onto the SD card into our root directory. We're going to plug the SD card back into our AGON. And now we should be able to do a load flash. Where is the underscore? There it is. I'm using a German keyboard layout here, so I have to accommodate for that a bit in my brain, which is still not quite awake. Yeah, this should load our software from the SD card. No such variable. We probably have to leave BASIC. So we're now in BBC Basic. So we have to do asterisk by. Now we're in AGON Quark MOS, which is the firmware operating system. So now we should be able to do load flash legacy bin. Okay, yay, okay, that's the catch. Okay, now we can do like direct addressing of things. So obviously I'm a noob with this system still. So this is actually the first time I ever use this thing. So we have to quit BBC Basic, which is auto-started on my unit, which is pre-configured to just run BBC Basic. And then we can load the Flash Legacy software from the actual AGON Quark MOS, which works fine with the command that is given in the GitHub README. So now we can flash our firmware and we can start the program by jumping to this memory address. One more zero. That should start the flashing process. Let's see. Yeah, there we go. And this is the legacy tool, obviously. Testing the CRC. Erase and program flash. Yes. Backing up existing firmware. So this should work without any issues, and we should start up the next time with the new firmware. Reset. Okay, it's auto resetting. Let's wait it out. Yeah, there we are. AGON Quark MOS version 1.02. Yeah, so we upgraded the firmware successfully. That's as easy as it is, really, if you are not a noob like me and try to do it from BBC Basic. You shouldn't. You should try to upgrade the firmware from the firmware. So let me just copy some of the example programs for BBC Basic and things like that to the SD card from the GitHub, which is going to be linked in the video description in case you want to take a look. I'm also going to link the AGON project page, obviously, so you can look at the code and the Gerber files for making your own circuit board. And the BOM, everything is freely available, so you can make your own if you so desire. So I'm just downloading the whole thing here, the manual and everything. So we have everything in a convenient zip file here. And we should just be able to copy across the microSD card files folder from our download. And I'm just overwriting everything with the new files, basically. So now we should have the latest examples on our SD card. And we're starting up with BBC Basic again, which is kind of nice. You can also update the code on the VPD, the graphics and sound processor in there, but I don't think there's an update for that yet. So we're back in BBC Basic. And we're going to look at some of the example files, which you can just load with the BBC Basic load command now. Let's do the triangles test. And we can run this with 1. And it's actually changing the screen mode and displaying random triangles. And this is interpreted basic, so it is a pretty capable little machine. Listed, this is the whole program. Changes the graphics mode with mode 0, and it changes the color palette with 3 random RGB values and then plots triangles and repeats. So that's the whole program that gives me the output we've just seen, which is pretty amazing. Pretty easy to work with. Yeah, my monitor here has some issues with the screen modes, I think, but works well enough. Let's try some other examples, shall we? So we should be able to clear the screen with a CLS. Yeah, we are. Can still list our program. We can catalog our directory with asterisk cat, all uppercase because all commands have to be uppercase. There's a scroller program. Let's try the scroll program. Scroll 1 BBC. Run. This uses a screen mode that is not supported. Yeah, this uses mode 2, which my monitor doesn't seem to support. We're going to have to find a workaround for that, I guess. This is an old television, so it doesn't support all the regular VGA screen modes. Probably if you hook up a proper VGA monitor, it should work. Let's load the Cube demo. BBC run. And we have a rotating cube, 3D programming. And that's a bit more sophisticated. Let's run it again in another wireframe. Mode 0. Yeah, this is the highest resolution screen mode, I think. And I mean, it's basic, it's interpreted basic, so it's not going to use the full speed of the processor because it has to interpret. It's a basic interpreter. But yeah, Mandelbrot. Yeah, so obviously I could play with this all day, more or less. Well, let's try something else. And this is a Mandelbrot program that draws the Mandelbrot figure on the screen. And it takes a while, so I'm going to be back shortly. Yeah, so that took a while to run, but we now have our Mandelbrot display here. And looks kind of neat. And it ran way faster than on the old school 8-bit systems, where you would usually leave the system on overnight or something like that to get a picture like this calculated and output to the screen. So yeah, this is the code, which is not very massive. You can see that it's pretty easy to plot stuff on screen and change the color and things like that. The rest of it is the calculations necessary to generate such a picture here. So as it turns out, there actually is a firmware update for the VDP chip, the ESP32 chip that handles the graphics output. And the newer examples require that newest firmware version. So we're going to have a chance to look at the update process, which should be pretty straightforward. We are going to use the Arduino IDE. And I have connected the AGON to my old ThinkPad here via the same USB cable that the power runs through. That should also be the programming port for the Arduino chip that's on here, actually, for the ESP32. So yeah, let me download the firmware and we're going to try to upgrade the firmware on the VDP. Actually, the AGON is powered through my ThinkPad now, so that works. If you have nothing connected to the I/O pins there, we have enough juice on a regular USB port to power this thing. So I am on the GitHub for the VDP firmware, and there is a walkthrough about how to pull this off, updating the VDP, which I'm going to follow. I'm going to download the latest release, which should be the source code zip file here. Going to unzip that and we probably should be fine. We have to make some settings in the Arduino IDE, which is a free download on the Arduino CC website. Select preferences from the file menu and copy this string, this URL. So file preferences, this is all in German on my end here, I'm sorry. Yeah, we need to put this into additional board manager URLs. Okay, we have to select the ESP32 board, making sure version 2.0.4 is installed. Okay, board manager. We have to click on board and then there's our board manager on top there. Okay. ESP32, there we are. 2.0.7. I guess we're going to be fine with the newer version. The walkthrough says 2.0.4 should be installed. Let's install this. Okay, this is downloading all the necessary tools for ESP32 dev boards that we're going to need to be able to program this, because this basically acts like a dev board. And after we have downloaded and installed everything from this package, we should be able to select the board and configure it according to the plan. Now the board can be selected and configured. From the Tools Manager, ESP. Okay, ESP32 dev module. We should be able to configure this. Okay, 92, yeah, that's correct. That is correct. That is correct. QIO is correct. Flash size is correct. Yeah, that should all be correct. And we need a third-party library, FabGL, from our library manager. Library manager, FabGL, version 1.0. Let's go with the version that is indicated in the walkthrough. Yeah, that has the VGA stuff and things like that. FabGL is the library used to make this into a graphics chip, I guess. Now it's another bit of installation process that I'm going to skip for the video. And then we're probably good to load the sketch and compile it and upload it to the VDP, actually. We can probably go to our downloads folder, select our AGON VDP and load our video sketch. So that's our AGON video BIOS. Jeroen Venema did the sprite code, Damien Gard did the fonts, which are BBC-like fonts, if I'm not mistaken. So let's see if this compiles. No such file. Okay, we have to include our files. Okay, it needed some more fiddling, but now I got this to compile and I'm pretty sure that this is what we need. What I did was, in the documents folder, actually, there's an Arduino folder. This is for the Windows version of the Arduino IDE. There's an Arduino folder, and in that folder there's a libraries folder. And I made a directory called AGON and just put all the .h files from the download of the firmware into that. And the libraries folder in the documents folder is actually auto added in the Arduino IDE. So you have to restart the whole Arduino IDE. I loaded the sketch again and now it finds everything it needs, it seems. So probably it's a good time to start programming our ESP32, maybe. Let's try. And yeah, just as a precaution, I don't know if this is necessary, I'm just going to quit BBC Basic with *by. So we should be back in AGON Quark MOS. And now we should be able to program. Fingers crossed, this is going to get to something. Okay, it's going to compile again. And then it is going to upload it, hopefully. This takes a while. The whole compilation process took several minutes on this elderly ThinkPad, but it got through. So chances are we're going to end up with an updated VDP. I'm going to report back. Connecting to the serial port. Writing. The AGON actually did a little beep and shut down, it seems. So it's now writing to the ESP flash memory. And it restarted. And we now have VPD or VDP, I don't know, it's not coherently labeled, version 1.02. Success! So apart from me being a noob with the Arduino IDE and taking some wrong turns there, this is actually not that difficult to do. So we're now on the latest firmware, both on the VPD, VDP and Quark MOS software. So let's try some more sophisticated demo stuff on the AGON. So rebooting the AGON by plugging the USB power supply back in. And this is how long it takes to boot up. This was real time. And sorry, I'm just filming the screen here. I don't have a proper VGA capture device. Okay, we have Animal. Let's load Animal. That should be some kind of game, I think. Guess the animal. Are you thinking of an animal? That's AI right there. The future, everybody. Does it fly? I'm thinking of an animal. It doesn't fly. Does it live in water? Part-time, I'd say, so maybe yes. Is it a mammal? No. Is it a fish? No. Does it have a hard shell? No. Does it have 8 tentacles? No. Does it have a nasty smell? I don't know. I'm not sure. No, probably not. Is it a frog? No. Okay, I give up. It is a penguin. Please tell me a question that would distinguish a penguin from a frog. Does it have a beak? For a penguin, the answer would be yes. Yeah, let's just try them all out, I guess. So to counteract the screen modes that my monitor doesn't support, I actually remembered my OSSC upscaler, which supports VGA inputs. And I was able to get this to somewhat work and to display on my screen using the OSSC connected to the AGON. And this is one of the scroll demos in one of the screen modes that didn't work. So it can do smooth scrolling with the new VDP firmware, as you can see. Unfortunately, parts of the screen are cut off, as you can see here. That's the OSSC. I'm not sure how to counteract that, but we're just going to load some other demos here. So this is examples how to use game code, basically. This is the smooth scrolling that's implemented here. And of course we can list this, that's the whole program for the scrolling. So there's a VDU command, which is, I think, that should be the one responsible for the scrolling. This is a sprite demo. These look pretty smooth as well. Let's load another sprite demo. And obviously these are just examples about what this could do potentially. Running that one. That's even more sprites. So apparently it seems it can do a lot of sprites. That's the Pac-Man-like ghost there. Or many of them. Multicolor sprites. Nice. Okay, what else do we have here? And you can see that the sprites actually behave like sprites. Let's see if they are removable with the CLS command. No, they aren't. Just like on your old school computers, they are independent of the rest of the graphics output, which is kind of what sprite means. There's a lot of benchmarks in here, all standard basic benchmarks that we are not going to take a look at. I think it's not that interesting. But these were put there because the claim that this is the fastest 8-bit system on the market as a single device was kind of backed with facts. So they ran a lot of benchmarks on this thing and compared it against other 8-bit computers, current and old school ones. So there's a sound demo that we didn't look at. And apparently this actually has a little sound output. So we're going to hook up a speaker, if I can find it. This is my little JBL speaker. This is a stereo output, but I'm recording the video in mono anyway. So this is just a mono speaker that I'm connecting because you wouldn't hear the difference. Let's load the sound demo, I guess. Load. Okay, that's some very old school 8-bit sound there, probably square wave. And yeah, this is the whole code for Amazing Grace. These are the notes probably, and we have the sound command that works with the sound output on the AGON as well. Yeah, I guess we've looked at all the examples that are on there at this point. Yeah, those were some BBC Basic examples running on the AGON. And obviously, since this is completely open source, the firmware, the hardware and the software, you can modify this to whatever you want it to do, basically. You can program the little Z80 chip there using the Z80 programming kit. Even in BASIC, you can do pretty amazing stuff. And we're going to look at another thing that this thing is great at in a second, and that is the GPIO pins can actually be addressed via the BBC Basic, which makes this relatively easy to work with if you're not familiar with Arduino stuff like I am. The AGON Lite obviously has a GPIO header sticking out the side here, which is actually a fully programmable GPIO header, as you are probably used from your regular microcontrollers and Raspberry Pis and things like that. And I have installed my very, very sophisticated test rig here, consisting of an LED connected through a 4.7 kilo ohms resistor to a ground pin on the GPIO header, and I've connected pin 17 to the anode of the LED. So let's see what we can do with this LED through BASIC. Let's see if we can make it light up at least. So the GPIO header is completely addressable through memory addresses in the Z80 processor. So we can actually talk to it through BASIC commands. In standard configuration, they are all set to inputs. We can see that by reading memory address 159, which are the C portion of the GPIO pins, are all set to inputs. We can set them to output, which we want for our LED, by setting memory address 159 to 254. That should put our pin we connected our LED to the output mode. And then we can address this pin with the command 158 1 for on. So let's see if we can put power with the command to our LED, hitting return. Yay! So that's literally how easy it is. And if I set that memory address 158 to 0, the LED should turn off again. Which it does. Nice. So that's obviously not the most sophisticated demo, but it is that easy to address the GPIO pins. Just wanted to point that out. And it would be pretty easy to come up with a program that makes the LED blink or something like that. And there's a little example program on the SD card here that shows me how to actually use these in a program in a bit more sophisticated way. We can basically set these pins. These are the B pins on the GPIO header, the addresses for those, and the C pins, the addresses for those, as hexadecimal values. We can set these in variables and then use those variables to address the pins, basically, which is pretty easy to do. I find this way easier to understand than programming in Arduino with the Arduino IDE, basically. So this is more my kind of style of programming, BASIC, as I said. Just to give you a quick example of how this is doable in BASIC, actually. And obviously you can do more sophisticated stuff than I came up with for this quick demo here by just reading data from GPIO pins, writing data to multiple GPIO pins, and all from the cozy BBC Basic interpreter there, if you so desire. And since this is one of my videos, we are obviously going to try to take a look under the hood here. Let's open this up and see how this is constructed, actually. There we go. So that's everything that is on here. We have our little reset button. We have the USB port, which has a little USB bridge controller here, this little chip here. We have our VGA port. We have our audio output. We have our PS2 port for the keyboard. We have our little SD card, micro SD card reader here. A little beeper speaker that can output some annoying sounds. We have a access bus header, which allows us to plug in like little OLED displays and things like that into here. This can be used as an I2C bus. We have RAM. This is 512 kilobytes of parallel SRAM, static RAM. This is our Z80 processor, an EZ80F92, running at 18.432 megahertz, as I said. We also have our little ESP32 Pico D4 running at 240 megahertz. This is used for the graphics output and the sound generation, basically. This is the coprocessor. This is the main processor, the heart of the machine. We have some jumpers that we don't really have to fiddle with. These are just here in case something goes wrong with the ESP programming, basically. You can manually set this to be not in programming mode in case this crashes or something like that, because the ESPs can have some quirks sometimes. We have some basic ESD protection, which is pretty nice. Some transient voltage suppression diodes on all the ports, especially visible on the GPIO port here, which is this one. We didn't even talk about that. And we have a little voltage regulator. This whole thing internally runs on 3.3 volts, so we need a voltage regulator to regulate the 5 volts input coming from the USB jack here. You can also power this through pins on the header, I think, which makes this even more versatile. So you don't even need to plug in a USB cable here to run this. You don't have to use the graphics output. You can basically run this like a microcontroller and just hook stuff up to the GPIO pins. So that's all very versatile, as I've pointed out. Everything here, the processor and the little ESP and the SD card. You can change software, firmware, things like that around to your liking. You can program everything to your liking even. Super small, super low cost design, which was the goal of the whole project. And this is still a true 8-bit processor system with a real Z80 processor, no FPGA, no emulation in here. The ESP, as I said repeatedly, is only for graphics and sound output. Everything on here is still readily available. All the components should be pretty easy to source, even with the component shortages at the moment. So it should be pretty easy to make your own. And you can also buy these pre-made from several sources now. They are listed on the website. We're going to take a look at that. In addition to that, the whole project is aimed at the community, to be a community-driven project. So you're not only allowed to, but encouraged to build your own boards and to even sell them. Bernardo himself made a video on his channel talking about how to set up production for these and actually sell these. So that is encouraged by the creators of the board. They are not making any money off of this. They put a lot of time and effort into this just to see this project see the light of day and put it out there for free, completely open source, open hardware. Everything is hackable and changeable to your liking if you understand how that works, unlike me. So I wouldn't be able to change the firmware code myself or something like that, but I can still use this from the basic that is also available for free for this machine. You just have to boot that off the SD card, as we've seen. So pretty neat project, and especially neat since this is all openly available and easy to get your hands on and not that expensive. Let's take a look at some of the websites that already sell these. So here we are on the AGON site on Bernardo's website. He also designed the Cerberus that I made a couple of videos about. Talos is another project that's still in the making. He made several adapters and things like that. So it's a pretty nice website anyway to look at if you are into retro computing or tinkering or tinkering. This is always updated pretty quickly when something new arrives for the Argon Lite. This is the board like Bernardo designed it. There's also a 3D printable case design that is openly available for the Olimex version of Argon Lite. Olimex is one of the places that sells it, and they actually changed the hardware slightly. They modified it slightly to optimize it, as we're going to see. There's several magazines, and Hackaday also had a little article about the Argon Lite already. There is a native 4th interpreter now for Argon Lite, and there's probably going to be even more projects for this in the future if the word gets spread, which I hope to foster with my little video here. Yeah, Olimex offers a lower cost version of Argon Lite, which is pictured here. They made some changes to the layout here. You can see that all the output pins are on this side here now, and they also got rid of the linear voltage regulator, I think. So we have a list of media coverage here, and we have a list of where to get this. Olimex actually sells their own version, which is kind of a cost-reduced version, but it has the same functionality, and that's literally 50 euros to buy. Olimex is located somewhere in Europe, I'm not quite sure where, but if you are in Europe, you won't even have to pay hilarious shipping or customs fees or anything like that. So this is just super easy and super inexpensive for a system like this. PCBWay offers this pre-made for $119.99, but this is produced for you, so that's probably justified. They have a bit of work with that. That's not mass-produced. We have an Australian reseller already, Argon Lite AU, where it costs 150 Australian dollars, fully assembled with firmware and with the case that we've seen. And there's several other options without through-hole parts or only the PCB. Only PCB is $20. So there's a number of options to get these. Reinhard Schuh in the UK offers options for ready-to-use units, which are probably also not that expensive. £75, £85 fully assembled. If you are in the UK, probably worth considering. And on here we also see the benchmarks that they ran, proving that Argon Lite indeed is faster than anything else that's currently available. Cerberus is pretty fast already, but for example the Spectrum Next and the old systems, the original Z80 systems, are significantly slower than this thing, obviously because it runs at a vastly higher clock speed, and it's still a Z80, just a modern one, an optimized one. And there's even a benchmark against the Commander X16, and it beats that too, as you can see here. That's a quick overview of the Argon Lite, which I still have in pieces here. Yeah, as you've seen, it's a pretty versatile little thing that can do lots. It still is an 8-bit microcomputer, which is kind of amazing. The most amazing thing about this, in my opinion, is that it's fully open source in the truest sense of the word, and that it's pretty low cost, as you've seen, even if you get a pre-assembled one. And it's readily available from a number of sellers now. Probably there's going to be more options to buy these in the near future, because as I said, the team themselves are not making any money off this. This is fully open source, and they are actually encouraging people to sell these on eBay, on their own websites and things like that. So we are going to have plenty of those in the future, hopefully. And hopefully there's going to be a lot of people developing stuff for this. There already are developments for like CPM running on this thing. As we've seen, BBC Basic is already natively supported, and Forth is also already implemented for this system. It is capable of playing some games and things. We've seen some scrollers and some sprite demos, so I hope this is going to see some development. And unlike the other projects that I've shown here, this is really not that expensive and potentially very useful for a lot of use cases. And even as a standalone 8-bit system, it is super nice to tinker with, and you can program BBC Basic stuff on this and relearn maybe your basic skills. So I think that's it for today. I hope you enjoyed this little excursion into the world of a new 8-bit microcomputer. I'm going to be back with older computers pretty soon. Check the links in the video description. I'm going to update those in case something new appears, but I'm definitely going to link to the GitHub project and the Argon page from Bernardo, so you can read up additional information that I didn't manage to include in this video or forgot to include. Thank you very, very much for your support on Patreon and on the channel memberships page, and also on Ko-fi. I hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.